Let's talk about the left and right Riemann sums and the relationship to the definite integral. So we're going to define what this is, the definite integral. Talk about left Riemann sums and right Riemann sums. So here's the left Riemann sums. I'm just annotating that LRS. You see that you do go from I equals 0 to the n minus 1. That gives you the left endpoint f of x values times your delta x. And the right Riemann sum, of course, is here, RRS, for I equal 1 to n of your f of x times the delta x, and that gives you your right endpoint sums. And what the definite integral from a to b is, a to b with this sort of sum extended sign here of f of x dx, is the limit as the n number of subdivisions goes to infinity of your left Riemann sum and your right Riemann sum going from 1 to n, and that's the limit as n goes to infinity. So those have to be equal to each other, and the limit has to exist. So if the limit does not exist, then the integral doesn't exist. And if the left is not equal to the right, then it doesn't exist either. So everything has to match up and exist for the definite integral to be defined. So here's an example. Let's say you take the function f of x equals x squared, and it's on 0 to 2. So your a number is your 0, your b number is your 2. Delta x will be b minus a quantity over n. And here's various n values. N going from 2 to 10 to 100 to 1000. So this is giving you the left Riemann sum values and the right Riemann sum values for various n's, increasing from 2, 10, 100, and 1000. So as you see, when you only have two subdivisions, that's just the same as doing this, where you just have this curve, and here's your 0, and here's your 2. That's just doing this. And for the left sums, you have this and this. And for the right, of course, you have this one and this one. And these are the two areas that you get, 1 and 5. Then you go on to 10 intervals, 10, and you get 2.28 for the left Riemann sum and 3.08 for the right, because now you have 10 subdivisions. Then you crank it up to 100 subdivisions, 100 rectangles. Now your left Riemann sum is now 2.6268, and the right Riemann sum is 2.7068. So they're getting closer together. And then when you take 1,000 subintervals, 1,000 rectangles, the left Riemann sum is 2.662668, and the right is 2.670668. So they're getting very close. They're only a little bit more than, actually a little bit less than 100th apart, but that's still not that close in the scheme of things. But if you increase this n size, and don't do that with your graphing calculator, don't get much higher than 1,000, because the processing time will take so long. You just have to turn off your calculator, and it might freeze up. So don't do too much more than 1,000. Anyway, the actual integral from 0 to 2 of x squared dx, and the dx signifies that the limit has been achieved going to infinity and that it exists. So instead of calling it delta x, We call it dx, notifying us that the limit has gone to infinity and that these delta x values have gone down to 0 in the limit. So we'll be learning how to do this, but the actual answer is 2.6666 repeated, which is 8/3, and we'll learn how to do that. So you can see that in the limit, the actual true answer is the 2.6666, and you can see that these left sums and right sums were indeed zeroing in on that number.